All right, for the last couple of days, what you've been given are the diagrams already drawn out for you, like what you see over here. Okay, where all you had to do was find one of the missing sides. So for the triangle or the vector diagram on the left, you'd have to find the angle of the resultant vector, or maybe you'd have to find the adjacent side, or what we would refer to as the x component and the y component of our vector if you were given the hypotenuse and the angle. But today, what you're going to be expected to do is to be able to sketch out the diagrams yourself and then answer the questions from that diagram. So let's see what this actually means. We have a couple of sample problems here. We'll take number 3 for a starter. Number 3, it says a person walks 30 kilometers west, then 20 kilometers north, then 15 kilometers east. What is her displacement? So you kind of have to envision how much space you're going to need for this. So it says that you're going to walk 30 kilometers west. Okay. So we'll just say that that is 30. We have kilometers due west. Okay, 0 degrees west. And then they walk 20 kilometers. We have 20 kilometers, and that's going to be due north, 0 degrees north. Then it says that we're going to come back east 15 kilometers, and again, that's due east, 0 degrees east. So we've got a diagram that looks something like this. So what you're left to try to figure out is, what is her displacement? Well, what we have to do is go back to where you put pencil to paper first. I put my pencil to paper first right here. That means that that's where my resultant is going to be drawn. So I'll draw that resultant to where the last vector was drawn. Okay, so the angle, since that's where I started at, that's the angle I'm going to need to find as well. From the information that you have, what we can do is easily, since this was created along a due west, due north, due east situation where we didn't have any angles involved with that, you can take the vectors and make yourself a right triangle from that, like this. Okay, how are you supposed to know the sides? Well, you kind of already do, because this length right here, the y component, that's still going to be 20 right here. That's still going to be 20. All right. Now, the other part of it, the 15 kilometers along the x-axis, we know that the whole length from left to right was 30. And if this part right here is 15, then that means that this part over here is 15 as well. Okay, so you have your sides. You have your opposite side here. You have your adjacent side right here. You're left to find the resultant. Now, what this involves is this side right here. That's your hypotenuse. And we need to find theta. You have two sides of the right triangle. You got 20, you have 15. So I'm going to choose the easy route out. I'm going to use the Pythagorean Theorem and say 20 squared plus 15 squared. If I get the square root of that, that's going to give me my magnitude of the resultant. And then my angle of this, since I have the opposite side, 20, and the adjacent side is 15, I can use tangent. So I'll say inverse tangent is opposite 20 divided by adjacent 15. That's going to tell me my direction. So we'll put that into the calculator real quick. And we have square root. You always need to make sure that you use your parentheses correctly. Excuse me. We have 20 squared plus 15 squared. Close that. So I know that my magnitude is going to be 25 kilometers. That's how far that they would have walked along the path from beginning to end if we had a straight line from beginning to end. And then the angle that they're going to take, we have inverse tangent, 20 divided by 15 at a 53-degree angle. So we have a 53-degree angle, but we can't just leave it as that, because what happens if we had drawn our diagram a little differently? What happens if we would have started with the 15 to the east, and then we did the 20 north, and then we did the 30 like this? What would you end up with? We'd have still the exact same vector, the exact same resultant, but the angle that we would be describing, if we had everything drawn the same, would be the complementary angle to the previous. Okay, do you see that? That this angle right inside of here, had we chosen to begin with a different vector other than west, then north, then east, if we had used east, north, then west, we would have come up with the complementary angle. So you will have to make sure that you explain, with respects to cardinal directions, the angle at which you are describing. So that 53 degrees, what exactly would that be? Well, if this is due west, if that's 0 degrees west, I need to go off of west towards the north by 53 degrees before I can get to that red dashed resultant vector. So that means I would have to go 53 degrees north of west before I would get to it. All right. Now that's one example of a diagram that you're going to have to be able to draw out. And it's just a matter of you sketching the stuff out and then filling in your stuff. Okay. Let's do another example. This time, let's go with, let's say number 5 here. We'll choose number 5 just because it's not going north, south, east, west. This one's talking about an escalator that lifts a person vertically at 1 meter per second. So if it's going to lift somebody up, that means that we're going to have the arrow that's going to be drawn up at 1 meter per second. It says simultaneously moving the person 3 meters per second horizontally. So it's also at the same time going to have a horizontal component that's 3 meters per second. So the escalator, if you could imagine it, okay, you see how bad my artistic ability here is. If this is the escalator, okay, you have a person that's standing on the escalator, and as, let's see if I can get this, as the escalator moves upwards, it's also moving forwards at the same time. Okay, so we're trying to figure out what this resultant velocity right here is of the motion of that person. Okay, now since we started at the bottom of the escalator, that means that that's the angle that I have to find. Now, with any vector, you have to have the magnitude and you have to have the direction with them. Okay, since I have 2 sides of my right triangle right now already given, I'm just going to choose to use the Pythagorean 1 squared plus 3 squared. Boy, that looks awfully close in there, so we'll do that. And then, like we had before with the top one, since I have the opposite side and the adjacent side, I'm just going to use tangent for it. So I have tan -1 equals 3 divided by 1. And then we throw all that good stuff into the calculator, and we figure out what we end up with. So clear, square root, parentheses, 1 squared plus 3 squared. You're going to have 3.1, let's just go 3.2. 3.2 meters per second. And then our direction, we're going to have inverse tangent, 3 divided by 1, opposite divided by adjacent. And you have a 71.6 degree angle associated with this. Now, since this one was being described from vertical right here, what we would say is that would be 71.6 degrees off vertical, like that. Okay? Now, we're going to get into the fun stuff. I say that because I like them, but we'll see if you guys like them as well. They're called riverboat problems. Riverboat problems are not an issue so long as you stay organized. So, number 7 is a perfect example of a riverboat problem. Okay, you have a motorboat and it's going to head east at 15 meters per second directly across a 400-meter wide river, in which the current is moving at 7 meters per second to the south. It says calculate the boat's velocity, calculate the time, calculate how far downstream you got, calculate your angle upstream. It's got a whole bunch of stuff, but if you start out with a simple diagram and you do a good job labeling it, you're not going to have any problems. So, you got a river. All right, so right here, you've got your river. All right, and we know that the boat is going to head across the river. So if it's going to head across the river, I'm just going to put my vector across the river like this. And it's going to head across the river at a velocity of 15 meters per second. It says that the river is 400 meters across. So across, if this is one side of the river and that's the other side of the river, that means that it is a distance in between those two x's of 400 meters. It says that the river is flowing to the south. Okay, so the river is going to move downwards like this at a velocity of 7 meters per second. All right. First part, it's the easy one. You just have to figure out what the velocity, the resultant velocity, is going to be from your horizontal component and your vertical component in the picture. So that's just this vector right here. Same old information. Nothing new with this. So I'm going to put A down here because this is broken up into 5 different parts. So we have to get the angle and I have to get the resultant velocity. So I'm going to use, again, it's the same old thing. You're going to have the Pythagorean. You've got 15 squared plus 7 squared. And you have tangent, -1 is opposite 7 divided by 15. All right, now we have to get these values before we can really go on to any other information and figure out what we've got. So let's do this. Say square root. We have 15 squared plus 7 squared. The resultant velocity of our boat moving not just across the river, but across and down the river is a speed of 16.6 meters per second. And the angle that it's going to be moving across and down the stream is going to be, oh, here we go. I didn't have the inverse tangent. knew something was weird because there's no way that that angle that we drew in there could be a 0.008 angle. So that can't be right. I didn't hit the shift. Okay, now we're going to get the right thing. So we go 7 divided by 15, and now it's a 25-degree angle. And since this is looking at moving south, okay, since we said that this is south and this is east, that means that we'd have to go south of east. So 25 degrees south of east. All right. So your boat, you got your little sailboat or your motorboat here, and this boat is going to move across the river. Now, if the river did not flow at all, the boat would just go straight across. But the thing is your boat, as it moves straight across the river, it's going to be pushed down at the exact same amount of time, okay? So as it's moving across the river, it's being pushed down at the same time, okay? So it ends up having a resultant velocity of 16.6 meters per second, and the angle that it's going to be pushed downstream would be at a 25-degree south of east angle. So we go to part B here. Part B, it says calculate the time it takes for the boat to cross the river. Now, please pay attention to this carefully. Okay, B, part B here. You're trying to figure out how much time it takes to get across the river. We said a little bit ago that this is one side of the river here. You have the other side of the river here. So that means that the distance in between those 2 points is 400 meters. All right. And we're trying to figure out how long is it going to take to get across the river. So you have now 3 different velocities. All right, 3 different velocities. And we're going to look at each one of these independent of each other. So we have the first one, the 15. That means that that's the boat moving across the river. Okay. The 7 meter per second would be just looking at the moving down the river. And then the resultant would be the velocity moving across and down the river. So if we're trying to figure out what is the time to get across the river, I'm going to use the distance across the river and the horizontal velocity across the river. Okay? So for every single second that boat moves 1 second here, it moves 1 second here. So it's going to be the exact same distance. After 2 seconds, that boat will be the same distance here. After 3 seconds, 4 seconds, 5 seconds, it's always going to be the same distance across the river. So we don't want to use the 16.6. We've got to use the velocity across the river. So if we're trying to figure out the time across the river, I need to go back to my kinematics formulas. Velocity equals distance divided by time. We're trying to find the time across the river. So we're going to rearrange this. We're going to have distance divided by velocity. The distance, again, emphasizing this, distance across the river is 400 meters. The velocity across the river is 15 meters per second. So how much time is it going to take for that boat to get across the river? 400 divided by 15 gets you 26.7 seconds. So the time to get across the river, 26.7 seconds is what it's going to take to get across the river. All right. Says, letter C, how far downstream will the boat be pushed as this boat is moving across the river? All right, now, time is an independent variable, okay? It doesn't matter if that boat is moving across the river. It's going to take 26.7 seconds for it to get across the river. But you have to understand that for every single second that it is crossing the river, it's also being pushed down the river. Okay, so if we are on the river getting across and it's taking 26.7 seconds to get across, that means we're going to be pushed downstream for 26.7 seconds. To figure out how far downstream you're going to go, we know the time that you're on the river for is 26.7 seconds. So to figure out the distance, we use that kinematics formula again, where it's going to be velocity times time now. The velocity is 7 meters per second times your 26.7 seconds. And we're going to end up with, I'm just going to cheat, I'm going to go times 7. Will be 186.7, we'll just say. 180, was it 180? Stinks getting old, your memory goes on you. 186.7. Okay, so we have 186.7 meters downstream. We have part D, you have this, and this is real, but you know, before I actually get to D, let's look at one last part. And I know this is not on the question, but let's just say that this question asked, we know the distance across the river, that's going to be that 400. We know how far downstream that thing is going to be pushed. It's going to be pushed downstream 186.7 meters. What would happen if I would ask you, what's the distance along the resultant path right here? Okay, there's a couple ways that you could solve for that. You know your angle, that's going to be the 25 degrees. You know the across component, that's 400 meters. You know the down component, that's 186.7 meters. You know the angle of this is 25 degrees. So you could use, in this case, you could use sine to figure out what the hypotenuse of your distance diagram would be. You could use cosine to figure it out. You could use the Pythagorean to figure it out. So I'm going to choose to use the Pythagorean, and I'm going to go with, where did that come from? Save 2. Uh-oh. Here we go. When at first your calculator fails, you quit it. All right. Now we'll get back in here. There's my square root. So I'm going to get the square root of 400 squared plus 186.7 squared. And the distance along the resultant path is going to be 441.4 meters. Now, why am I showing you this? Because I wanted to show you, if we look at that time variable, I said time is going to remain constant no matter if you're moving across or down or across and down at the same time. If our distance is 441 meters, okay, so distance equals 441.4 meters, and I know the time was the 26.7 seconds. Well, if I wanted to figure out the velocity of the resultant vector this way, what's it going to end up being? So I divide by the 26.7. What do you end up with? You end up with what the resultant velocity is right here. Okay, now I know you might be saying, wait a minute. You got 16.6 and the answer on your calculator says 16.5, but didn't we round off a couple times? So there's all kinds of different ways that you can solve for that. You just have to make sure you've got all your stuff lined up in gear. You got to have it all ready. Now, for this next part, let's make some space here. And I'm going to cheat a little bit. I'm going to copy this. So we'll copy, and we're going to put it down here. And this is where it gets to be a lot of fun here. Okay, so we're making some space, and you'll see why I'm going to need to make some space here, because our boat, I don't want to get rid of that. Our boat, instead of it being pointed straight across the river, now we're going to have the boat point up at an angle. So it says, for this now, it says, calculate the angle upstream that the boat would have to head in order to end up directly across the stream, so it's not going to drift downstream at all. Okay, we said earlier that your boat, it's heading straight across and it gets pushed downstream. Well, this boat now, if I'm going to, instead of heading straight across, I want to know what direction do I have to point my boat upstream in order to come straight across with it. So this velocity right here, okay, that velocity right here, what angle do I have to take with that? Okay, well, first off, what's the velocity of the boat? The velocity of the boat was 15. That's what the boat's engine can do. So my boat engine is going to have a velocity of 15 meters per second. Okay. We want that boat to move directly across stream, but at the same time, that boat is going to have some vertical component here also that it's going to be fighting. Okay, so we need to figure out what this angle is right here. All right, now we know that the boat is going to have to fight the velocity of the stream, which is 7 meters per second. So what we're trying to figure out is what is going to be the angle here. And let's see, we have the opposite side and you have the hypotenuse. So that means I'm going to use sine. So for part, where are we on there? D, for part D, I'm going to have sine -1 equals 7 divided by 15. Okay, let's put that in the calculator to figure out my angle here. So you have, I did that darn thing again. I don't even know what I pressed. All right, well, like I said, when your calculator fails you, you quit it. Okay. Maybe I'll try not to hit that button, whatever it is I'm hitting. All right, so let's see. We have shift sine. We go 7 divided by 15. The angle, my boat has to point upstream in order to go straight across the river. It has to travel at a 27.8 degree angle upstream. All right, that's the only way that that boat is going to move actually straight across the river instead of moving across and down the river. Okay. Last part is, and I think I know what this is, calculate the boat's eastward velocity. So the boat, I can get rid of that now. The boat is going to be moving across the stream a little bit slower because part of its attempt at moving across the stream is going to be held back because it's fighting the current, okay? So part E here, you have to figure out what the adjacent side is. And there's a couple different ways you could solve for that. You could use cosine, you could use Pythagorean theorem, you could use tangent. It doesn't matter. Because as long as you have the angles, as long as you have the sides, that's all that really matters. So I'm going to use, just to make this a little bit different, I'm going to use cosine. So we have to figure out the adjacent side. Cosine is adjacent divided by hypotenuse. We're trying to find the adjacent side. So that means I'm going to have cosine of your angle, 27.8 degrees, times the hypotenuse of 15, cosine 27, close it, times 15 equals 13.4 meters per second. All right, now we could have solved that a couple different ways. Like I said, if you wanted to use the Pythagorean theorem, you'd have square root 15 squared minus 7 squared, close it up. 15. Oh, I didn't close. I didn't have a parentheses in there. So we have 15 squared. I did it again. Square root. Now I got my parentheses. 15 squared minus the 7 squared. Close it up. And you got your 13.3. Now, we don't care what the little extra change is. It's not always going to match up because we're using rounded off numbers. Okay? But we now have our first riverboat problem solved. Going back through the list, we know the resultant vector, 16.6 meters per second at a 25-degree angle south of east. Time to get across the river, 26.7 seconds. The distance downstream that it's going to be pushed would be 186.7 meters. The angle at which we have to point our boat upstream would have to be a 27.8 degree angle upstream, and that would make the boat move across the river in a straight path, not being pushed downstream at all, at a speed of 13.4 meters per second. All right. You won't feel comfortable with riverboat problems until you've done a couple of them, so that's what you're going to do today. All right? If you got questions, you know what you have to do. You got to ask.